Sanibonani, njani nina? Ngiphelekile ngayo makuba namhlanje. Ngiyajabula ukubona la. Manje isifundo sami siphelile. But now I'm going to speak in English. Okay. We're going to make a start straight away. We have got quite a lot of learners from other schools who are joining remotely. So in other words, they're joining via an online meeting, a team meeting. Workbook that we've given you. It's got too many examples in for us to finish today. We're only going to do a few of them. What we have got for your teachers is the solutions, all the answers. Right, so we've got at least one, maybe two copies for each school of the worked solutions for the whole workbook. For those people who are joining online, I will share the worked solutions on the WhatsApp groups as well, so you will have them. So ideally, before you write your trial exam, I think it's on Friday, am I right, for paper one? Yeah, before you write your trial exam on Friday, ideally you want to try and look at all of these examples. Okay, I'm going to ask us first up to all look at example D, and we are on page 2. All right, so you'll see I've already left out 3 examples. I just want you to try this example. And I'm going to ask Mr. Mabaleka just to walk around, see if anyone would like to tell us anything about this question, maybe even just how we're going to get started. What it's about exponents, okay? I'm going to write down quietly on the side here, I'm going to write down some laws of exponents. I don't want you to worry about those. I want you to try this question. Anyone tell us how we're going to start with this question? So Mabaleka, anybody got to tell us just what they've done on the first line, what they might have tried? Anybody? Okay, so a lot of our exponents questions are around having the same bases. Now, at the moment, we haven't got the same bases. You can tell me, how can we break 12 up, right, into its prime bases? I think I heard someone say 6 times 2, but 6 is not a prime number. 2 times 3. Okay. Sorry, that's not a very good 3, but anyway. What about 18? Well done. 2 times 3 squared. What about 8? 2 times 2 times 2, huh? 27. 3 cubed. Well done. Allah, Allah. Okay, now exponents is all around the laws and the rules of exponents. I've written some of them on the right-hand side here. Sorry, on the left-hand side. Okay, when we've got a product raised to a power, which one gets the power? The A or the B or both? Both. So both the 2 and the 3 must get that power. Kodwa, when there's a power already and we raise it to another power, what do we do to the powers? We multiply them. Okay, so our next line here is going to be 2 to the 2x plus 2. 3 to the x plus 1. Okay, now, what happens when we multiply numbers with the same base? We add the exponents. Okay, so let's do that on the next line now. What happens when we divide numbers with the same base? We subtract the exponents. Okay, so we're going to get 2 to the what? 3 x's are going to subtract 2 minus 3, negative 1. What happens here when we subtract sorry guys, I've made a silly error here, all right, and nobody's told me about it. Okay, this should be 3x minus 1, sorry, minus, oh goodness, I've made lots of silly errors and no one's told me. If I do that, guys, you must say how evil. Okay, now we are going to subtract. Okay, and what happens when we go 1, subtract negative 3? We get 4. It becomes 1 plus 3. All right. Now, remember, we want our answer with positive exponents. So the one that's got a negative exponent, we're going to put underneath and make it with a positive exponent. And that's our final answer. It's actually 81/2. Okay. We're going to go over the page now. And we're going to talk about solving equations. And I'm going to ask us to look at these two equations. These two equations really test our understanding, okay? Because what we want to do, we want to find x. I want to remind you something that we've spoken about before with equations. Think of an equation as a set of scales. It's balanced. It's balanced because it's an equal sign. If we add 3 to both sides, will it stay balanced? Yes. If we add 3 to one side, 4 to the other side, no, it won't stay balanced. So we need to do the same thing to both sides. We also need to do these things in the reverse order that they've happened. Okay? So for example, if I've got a number 2 times x plus 3 and the answer is 11, right? I want to undo what is happening to x here, but I need to undo it in the reverse order. Listen carefully. X is being multiplied by 2, then we are adding 3. Times 2, then add 3. Now, when I undo this, I must undo it in the opposite order. Previously, I've spoken about getting dressed. You put on your underpants, amabulukwe, then your shoes. When you get undressed, which ones come off first? The shoes. We get undressed in the reverse order that we got dressed. So when we undo here, what's the undoing of adding 3? We're going to subtract 3. What's the undoing of timesing by 2? Divide by 2. Okay, let's try these two examples. I'm going to ask Mr. Mabaleka to walk around and see if he can. I really would love someone to tell me what, even if you can only tell us one thing, what we might do next. Okay. I want to get X. Even a first step, Mr. Mabaleka, you can just ask someone. If they've done the first step right, you can ask them to tell us. Anybody, you can put your hand up if you know what the first step is. You can just tell us your name and just tell us the first step. First minus B from which side? From both sides, actually. Eh? We're not minusing it from one side. We're actually minusing it from both sides. Does it make sense? It always makes sense. Okay. Who can tell me what should we do next? Divide both sides by A. Manje. We've now, you've heard me say this before as well. All right. Now, I want to get rid of this exponent here. I want to end up with an exponent of 1. What? If I put an exponent over here, will I add or multiply using my exponent rules? I will multiply. What power, what fraction will multiply with P over C to give me 1? Okay, well done. If I do that on the left-hand side, I've got to do that on the right-hand side. Otherwise, I'm destroying the balance. Remember the balance always when we're solving equations. Okay, so this is going to be C over P, and that's actually my final answer. Is going to be G minus B over A to the C over P. Examiners like these questions because you can't use a calculator to help you here. All right, let's try number D. Number D, hey, yes, corner fraction, mind you. What are we going to do to get rid of the fraction? Multiply by X. On which side? Both sides. La. What do I get, Mr. Mabaleka? Maybe you could just ask someone to tell me, what do you get if you multiply both terms or all the terms on both sides by X? So get a microphone, someone, quickly. Quickly. Don't be shy. Okay, one of the things we want to build in you is confidence. All right, have a go. Just talk. Just pass the microphone to someone, Mr. Mabaleka. Tell them to tell us. What happens? What happens? If you multiply both sides by X, all the terms on both sides. Allah, well done. Okay. Manje Nancy Kinga, because we've got X's on both sides now. Okay. Let's subtract BX from both sides. Remember, I want X on its own on one side. When I'm done there, then I'm done. Nancy Kinga, X is in 2 places. What can we do about the fact that X is in 2 places? Hey, well done. Halal. Okay, so we're going to take out an X. What will we get inside? C minus B. Manje, X is being multiplied by C minus B. How do I get rid of multiplying by C minus B? On which side? Halal, on both sides. A over C minus B. Okay. All right, I'm choosing the questions carefully because some of the questions we're going to come across later in other branches of maths. These are just some equations just to get us started. Okay, I want us to try and do this question here, right? Because this is an important skill. Before we do it, I want to do a simple one with you guys. Write this one down. So I want to solve this equation. When I'm done, I will have something like this. Does everyone agree this has not got an x in it? So let's get rid of this here. How can I get rid of this -1? Add 1 to both sides. Now, x is in two different places. If I can write this like this, something very clever is going to happen now. X will have gone from being in two places to one place. And if I'm trying to find X, it will be useful if it's only in one place. Now, what happens? Okay, and I know you guys are going to think, Paul's, hey, what's happening now? Okay, there's a square plus ihlanzi. Right. When you square that, what do you get? I'm actually going to call this a house here. A house squared plus ihlanzi squared plus 2 house ihlanzi. Okay. Now, guys, this here is so important. All right. When you square a binomial, you get twice. Whatever you put here, you're going to get this times this, and then it's going to be multiplied by 2. So what number must I put here so that when I multiply it out, I get x squared plus 4x? 2. Hala. If I put 4, guys, I'm going to get 8x. Okay, I didn't have 8x. I'm going to put 2. Now, when I put 2, when I square out the left-hand side, what will I get? X squared plus 4x plus 4. The fish squared, the 2 squared is 4. Did I have 4 on this side? No. By writing this like this, I've added 4 to the left-hand side. What must I do to restore the balance? Remember the scales. I must add 4 here. Okay. Manje, we've got x in one place only. How can I get rid of squaring? Square root, which side? Both sides. Don't forget, when you square root, you can have plus or minus. And what's the last thing we've got to do? Subtract 2 from which side? Both sides. Okay, and this is the answer that we get. Now, I'm not going to do this next one. Okay, I'm going to send you back with the solutions. But I am just going to show you the first thing we've got to do here is we've got to divide everything through by 2 because we don't want a coefficient there. Okay. I'm going to do 2 things at once here. I'm going to add 5 to both sides, and I'm going to divide by 2. Okay, I said I wasn't going to do the whole question. I'm going to do a little bit more. Let's just see if we can work out what must go over here. What do I need to do to this number? What did I do to the 4 to get to there? I halved it. I divided it by 2. What is half of 3 over 2? 3 over 4. Well done. All right. A half times 3 over 2 is 3 over 4. Broadway, what have I added that I didn't have before? When you square this out, what have I got that I didn't have before? 9 over 16. I need to add 9 over 16 to this side as well. Let's add these fractions just because we can. What fraction type can I use if I've got 2 and 16? What do they both go into? 16. What is 5 over 2 as a fraction out of 16? I've multiplied the bottom by what? By 8. So I must multiply the top by 8. Okay, so now we've got 49 over 16. Okay, I'm going to stop there, all right, just because we haven't got time to do all the questions. What you would do now is square root both sides. And remember, when you square root the 49 over 16, you must square root the top and the bottom. Okay, let's look at this one on the next page here, H. So we're on page 4. I really would love someone to put their hand up and tell us what we're going to do here. Yeah, there we go. Senator, the guy in front of you, right in front of you. He's going to tell us what to do here. All right. So what are we going to do first? Guys, we want to get rid of this. Okay, but we mustn't just square straight away because we've got a +4 here. Subtract 4 from both sides. What are we going to do now? Square both sides. Just careful when you square both sides. Remember the house and the fish? Yeah. So who can tell me, what do we get? X squared minus 4x minus another 4x minus 8x. Well done. Now this is a quadratic equation. Let's subtract x from both sides. Let's add 2 to both sides. Who can tell me the factors of 18 that add to 9? 6 and 3. What must we always remember when we've squared both sides? Do you know? We must check. Often one of these answers will not work. Let's have a look up here. If I'm looking at this line over here, if I put 3 in here, on the left-hand side, I get 3 minus 2 is 1. But on the right-hand side, I get minus 1. 3 does not work. If I try 6, 6 minus 2 is 4. What's the square root of 4? 2 plus 4, 6 equals 6. 6 works. Okay, let's talk about nature of the roots. And I'm just going to draw a little picture for you here. Okay, this thing here, because of where it is in the formula, it tells us about the nature of the roots of this equation, ax squared plus bx plus c equals 0. Okay, so if this delta, if it's less than 0, what can you tell me about the roots? No real roots. Your calculator gives an error. Right. If you've got, just find. Right. If we find the square root of -5 minus 6, we get an error. Okay. If delta is equal to 0, what can you tell me about the roots? They will be equal and they will be rational. They will be able to be written as a fraction. If delta is bigger than 0 and it's a perfect square, like 16, like 9, all right, then we will have unequal and rational roots. The roots will be able to be written as a ratio of two whole numbers. Quarter, if delta is bigger than 0 and it's not a perfect square, a number like 17, then what? Unequal, irrational. Okay, let's just look at this one over here. What's the first thing I've got to do before I can work out delta? I've got to put it into standard form. X squared plus 2x minus 7 equals 0. So let's look now at what delta comes to. Remember, delta is b squared minus 4 lots of a is 1. What's c? -7. Minus 4 times -7? 28. 4 plus 28? 32. So tell me about the roots. If delta is 32, and I want you to think about 32 inside this root sign here. When you work out the square root of 32, sorry, the square root of 32, do we get a number that ends or a number that just carries on forever? Carries on forever. So the roots will be unequal and irrational. Okay, we're going to go to question number 4C. I'm going to ask Mr. Babaleka to just come here quickly. I want to show him what I want him to do next. Oh, no, oh, there it is. Okay. Right. Okay. Yeah, look which one's off. Oh, yeah. All right. So now let's look at this question. It says determine K if this thing has no real roots. Now, what must delta be for no real roots? It must be, well done. For no real roots, we want delta to be less than 0. Okay, now let's work out delta. Unfortunately, it's not in standard form. So the first thing I'm going to do is add 2 to both sides. Now we're going to work out delta. Delta is b squared minus 4ac. Okay, what's b? B is k. Minus 4 lots of 1 lot of c. I get delta is k squared minus. Now, 4 divided by 2 is 2 times k, and negative 4 times 2, negative 8. And I want delta to be less than 0. This is delta. Now, what have we got over here? We've got an inequality. Okay? And I didn't, if you look back on the earlier pages, there were some inequalities. I didn't solve those inequalities because I knew we were going to come across one over here. How do we solve a quadratic inequality? What do we ask ourselves? What do we do first? We factorize it. You can tell me, how does k squared minus 2k minus 8, how does that factorize? Four and 2, good. Which one's positive? Which one's negative? Negative 4, positive 2. Now, guys, what shape is this? If I drew this as a graph, is it a straight line? Is it a hyperbola? Is it an exponential? Is it a parabola? It's a parabola. Okay, it's a parabola, and it has solutions of 4 and minus 2. We want to know, where is this parabola less than 0? Where is it below the x-axis? This parabola is less than 0. It's below the x-axis from negative 2 to 4. Okay, and I can write that like this. Comma, I can write it like this. Must I put square brackets or round brackets? I must put round brackets because I'm not going to include 4 and minus 2. If I include 4, delta actually equals 0. And I don't want delta to be equal to 0. I want delta to be less than 0. Okay. All right. We're going to move to our next section. All right. And the next section I'll show you is I think we've just got someone. I'm just going to mute because I'm hearing the room here. So I'm just going to mute everyone here. Okay. All right. Otherwise, we're going to hear the other locations. All right. Now, I'm going to ask Mr. Mabaleka to come up, and he's going to do some of these. I'm going to walk around, and I'm going to take some questions. And I'm not going to take no for one answer. Yeah, please sit because it's easier to sit here. All right. Let's just give you this. That's true. Well, yeah, yeah. Just put that somewhere. Okay. Right. We go.
Okay, guys, let's look at question 1A. 1A and B. Okay, for 1A, so who can tell us what are we being asked to determine?
Yeah.
For 1A?
What are we?
Sorry? Yeah, so and this is it. Yeah. Okay, so we're looking for what? We're looking for the 20th term. Okay. So what's the standard formula for an arithmetic sequence? Okay, yes. What is it? So Tn. So D plus. Yeah. Is this? D. Yeah. And so, yeah. Yeah. So A is equals to 2, and then D is equals to 4. Yes. So we substitute. So this is 4. Oh, sorry. Yeah. So this is 20 minus 1 multiplied by 4. What's the final answer? The T20 is equals to 78. Yeah. Okay. Yeah. And how do we calculate the sum? 2, 2A plus 1. Okay. What's the value of A, guys? The value of A? A is equals to 3. And what about D? 3 over 2. So D is equals to 3 over 2. Okay, so sum of 30 terms for the sequence is 30 over 2. 2 times the first term, which is 3, plus, it's going to say 29, multiplied by 3 over 2. Final answer? Okay, did you all get this?
Yeah, listen. The sign up. Sweet.
Okay, we're good. One thing is that we cover the screen is to combine and another important piece of that when you're solving an equation. All things come back and forth.
Okay, so what type of sequence are we dealing with? Type of sequence are we dealing with? What is it?
If you divide by the fourth, you go 9 divided by, okay, 1/5. If we go 13 divided by 9, we do 1/5. If we go 20 divided by 13.5, we get 1/5. Therefore, we do that. We are making 3. Are we looking for a fourth or a fifth? So what's the formula?
What's the formula? N-1. Okay. Okay, and then? And I say what? 20.
So we. And
Six. And R is 3/2. Okay, do we have the value of n? That's what we're looking for, eh? N-1. Okay, we have a nice exponential equation. Okay. Divide both sides by 6. Yeah, divide both sides by 6, so I have 20 million. Over 6 is equals to -1. Okay. Using what? Using logs, okay? So how am I going to set this up? How am I going to set this up? Sorry? So I'm going to say a log, okay, of 2 okay, so 20 million over 6. That should equals to and -1. Okay, then how do I move on from here? So I add 1 on both sides. Okay,
what's our formula?
n is equals to 38, comma. Okay, is this my final answer? This is my final answer. Okay, so what do I need to so what was the question? What was the question? Find the first term to exceed what? 20 million. So what is my final answer? What is it? Okay, so what is it? Is it what? 39, 37? 39, right? Okay, so the first value to exceed 20 million will be 39. Okay, so therefore, T39, okay, will be to exceed.
Right, 20 million is not even. Okay, if it come out to exactly 38, then 20 million is 38. So it's not 20 million, and the 39th term will be first one will be bigger than 28.
Yeah, let's move into this 5. Oh, it's good. That was a lot. Okay, so which term in the sequence -1, 6, 17, 32 is equals to 899? So let's first establish what sequence are we dealing with. Okay, what type of sequence are we dealing with? Remember, common difference, common ratio. Okay. There's a quadratic, see. Yeah. So how do we so we have a first and a second difference for a quadratic sequence. So what's the first difference? Let's look at the first difference. It's what? 7. Okay, and then the second difference. Okay, 4. Okay, 4. Okay. Now, what is the general formula of quadratic sequences? Yeah. Sorry. And squared plus bn plus c. Okay. Now, so we want to what? We want to find the term, right, in the sequence that is equals to 899. Now, let's first work out what is the value of A, what is the value of B, and what is the value of C in the sequence. Okay, what is the value of A? Sorry? Okay. What do you guys say? A is equals to? Okay, how did we get?
So what do we do?
Yes.
Yeah.
Okay. So 3A. So 3A plus B is equal to 7. Yeah, so 3. Yeah. See.
That's not surprising. If it is one, you're gonna get the first term. But if the concept P is the first term of all things, what do you see? P is 4.
Yeah. Now my sequence is Tn is equals to. So 2n squared plus n minus what? Okay. Now, what am I looking for? I'm looking for the term that is equals to. Okay, so I'm gonna say 800 9 is equals to 2n squared plus n minus 4. Okay, now I have a quadratic equation. Okay, I have a quadratic equation. We have a number of ways to solve a quadratic equation.
Yeah.
And now what? Okay, so what do I need to? Yeah, so n is equals to 21, and I'm assuming the other root is negative, right? Yes. Okay, we're on page 6A. It's A. Six B actually. 6B. Okay, so I'm told that 3p plus 1, okay, and 2p plus 4 and p plus 8 are consecutive terms of a geometric sequence. What do you know about a geometric sequence? What do you know about a geometric sequence? Okay, now can you see I'm given the sequence in terms of what? In terms of p. Okay, so how am I going to find r? How do I find r? Yeah, I find the what? I find the ratio between what? Between the terms. Okay, so r. Okay, remember geometric sequence as a common ratio. Okay, so if I say 2p plus 4 divided by 3p plus 1, that should be equals to what? P plus over 2p plus what? Plus 4. Okay. Now, what do I do from here?
You want to get rid of the. In cross multiply.
We can cross multiply. So we're going to say, yeah, so I'm going to say 2p plus 4 is equals to 3p plus 1 multiplied by p plus 8. You guys understand what I did here, right? Okay. And then, so what do I have on the left? On the left, so what do I have here? So 4p squared plus p, so it's 2 times.
Remember, you got 1 plus 2p in the 4, you take 2 and you take them.
Okay, is equals to 8 plus 8, 16, right? Okay, it's the first term squared. Take the product of the 2. Okay, double it, and then you square the last term. Okay, now if you do the maths, this should equals to 3p squared plus 25p plus 8. I'm assuming you guys know how to multiply two binomials. Okay, and okay, so move terms around. So what is 4p minus 3p? So p squared. Okay, and then so this. Okay, so 16p minus 25 is minus 9p. Okay, and then 16 minus 5 is. So yeah, 16 minus 5 is. Oh, it's an 8. Yeah, sorry, it's 8. Yeah, this is 8. Okay, so this is plus 8. Plus 8 is equals to 0. Okay, my handwriting is terrible, guys. Okay. Now, from this step, okay, I can use my calculator, can I? I can factorize, eh? So if I factorize this, so I have what? So p minus 8, p minus 0, therefore p is equals to, or what? 1. Okay. Are we happy with that? Let's move on to question 8.
Yeah.
Okay, so guys, number 8. Let's look at number 8. Right. A tree grows 2 meters in its first year. Each year after that, it grows by 20% of the amount it grew the year before. Okay, so what we're going to do, let's just write down how much it grows in year 1. Let's write down the sequence. So 2. Okay, and then how much does it grow in year 2? 2 times 0.2. Am I right? Okay, because 20% of 2. How much does it grow the next year? 2 times 0.2 times 0.2. Because each year it is growing by 20%. Remember to find 20%, we're going to go 0.2 times. So each time we're taking 0.2 times the previous amount. Now, what sort of sequence is this? Is it arithmetic, is it quadratic, or is it geometric? It's geometric. What is A? 2. What is R? 0.2. Multiplying by 0.2. Now, this is how much the tree grows each year. Each term is how much it grows each year. I want to get the total height of the tree. All right. Must I tell, am I going to find the term or the sum of the term? Think about it. That sequence that we've got is the growth, the growth, the growth each year. Must I add them or the sum of the term? I must find a sum. Now, this tree actually never goes beyond a certain height, because what we've got now, we've got an infinite geometric series. Remember, if you look at your formula sheet, there's a formula for the sum to infinity. We'll find that formula to tell us what it is. Sum to infinity. O A over A over 1 minus R. All done. Okay. What does it say just after that formula? On that formula sheet? This formula only works when R is between minus 1 and 1. 0.2. So it's okay. All right. So now we're going to put the numbers into the formula. The sum to infinity is going to be 2 over 1 minus 0.2. Can someone do that for us on a calculator?
Yep.
Final answer? 2.5 meters. Okay. Guys, after a while, the tree is going to be growing by, like, let's say, grow by 1 milliliter. The next year is only going to grow by 20% of a milliliter. So it actually eventually is how much you grow in all, and it reaches a maximum height of 2.5 meters. Okay, that's the sum to infinity. Then number 9. Okay. What's the trick with trigonometry? What should we always do? Write down 3 terms. If we write down the first 3 terms, okay, so the first term here, when I is 1, we're going to get 2k plus 3. Now put a plus sign, because remember, sigma notation means plus. Now, what's the next term? 2k plus 3 squared. What's the next term? 2. Have we got enough terms to tell whether this is arithmetic or geometric? Yes, what is it? geometric. What is R? 2k plus 3. So R is 2k plus 3. When will we get convergent? Only when what? Well done. When R is between -1 and 1. So now we've got an inequality. So -1 less than 2k plus 3 less than 1. Okay. An inequality, just like an equation, just be careful if we multiply or divide by a negative, we've got to turn the signs around. But that's not going to happen here. We're going to subtract 3 from all the sides, the left-hand side and the middle and the right-hand side. Okay, so we subtract 3. What do we get on the left-hand side? -4. Less than 2k. And if we subtract 3 on the right-hand side, -2. Now we're going to divide all 3 sides, the left, the middle, and the right by 2. -2 less than k less than -1. As long as k is between those numbers, r will be between -1 and 1, and our sequence will converge. Okay, we're going to just do one last question on sequences and series, and that's number 10. Okay. They like these questions. Examiners like these questions with a picture. Sometimes they'll use matches, sometimes they'll use squares. Okay, let's you can tell me what you think we should do as a starting point. Maybe we should start with the show. Okay, I'm going to do one, there, 5, there, 90. Okay. We've got 3 types of sequences. Arithmetic. Geometry. Okay. Yeah.
First difference. Two. Okay. The value of A is 2 times. Yeah, so A is equals to 1. And then B, so it's 3 times plus B is equals to 4, therefore B is equals to. Okay, and then C, that's 1 plus C is equals to. Okay. And therefore C is equals to. So C is equals to -1. Okay, and the general formula is so n squared plus n minus 1. Okay, have we answered the question? So just determine the general formula. So what do we need to? We need to find the number of shaded squares in figure 25. Yeah, so we're looking for 225, which is equals to 25 squared plus 25 minus 1. The final answer is 640. Yeah.
Right. One. The formulas on on financial maths. There's 6 of them. Okay, so 6 formulas. Why'd you bring me? I've got it. Okay. The first question we're going to do is number 2. Right? It says, what annual rate compounded quarterly will achieve the same rate as 10% per annum? Now, I think those of you who I've taught before will remember I like to look at R1 for 1 year. If I have R1 and I invest it at 10%, all right, then I will end up with that. All right. I'm actually going to rewrite this 10%. I'm going to show you how I'm going to do that. It won't let me rub that out. Okay. All right. I'm going to write it like that. Now, you might be wondering, Paul, why are you writing it like that? Okay. Because this 10% is only applied once. All right. I want an interest rate that is going to take my R1 and it's going to be compounded quarterly, which means that I must take that interest rate and I must divide it by 4. How many times will it be worked out in the year? 4 times. Okay. What I should have started with here, it would have made a whole lot more sense to you, is we're just looking at this formula here. 1p, 1 plus I to the n. This is our standard compound interest formula. Right. So P is R1. There's my P value. All right. And guys, it doesn't matter. If it was R10, you'd have 10 on each side of the equation. It's not going to make any difference. How many variables are in this equation now? Any large one? Yeah, just one. All right. What power could I raise both sides to get rid of this 4? A quarter. On the right-hand side, I've got 1,1. I'm going to raise that to the power of a quarter. On the left-hand side now, I've got 1 plus I over 4. What should I do next to both sides? I'm trying to get I. Minus 1 from both sides. So I over 4 is 1,1 to the quarter minus 1. What's the last thing I must do to both sides? Multiply by 4. 1,1 to the quarter minus 1. All right, I'm going to quickly do that on my calculator because I want to show you something important here. All right, so I'm going to go 1,1. I'm going to go 4, 1,1 to the power of 1 quarter minus 1. Okay, and I get 0,096. It's basically going to be 9,645, so 9,65%. Okay, there it is there. I want to show you what I'm going to do now. I'm going to store this number. I'm going to go shift store and I'm going to put that number in A. All right. Now, if I have 100 Rand and I invested for 1 year at 10%, how much money will I have? Come guys, this is easy. What's 10% of 100? 0,1. So 10% of 100 is 10. I will end up with 110 Rand. Okay. Now, I'm going to show you that if I use 9,65%, watch what I'm going to do now. I'm going to put 100. I'm going to press equals on my calculator. What's happened now is that answer of 100 is stored in answer. There it is. Now what I'm going to do is I'm going to take that number. I'm going to treat that as my P value. and I'm going to go 1 plus my interest rate is A. All right, that's where I stored that 0.0965, the 9.65%. I'm going to divide it by 4. All right, now what this is going to do is it's going to work out how much money I've got after 1 quarter. That's how much I've got after 1 quarter. Now that answer is in the calculator's memory called answer. So if I press equals, the calculator will do that same calculation. It will put a quarter of 9.65% onto that amount. That's how much I've got after 2 quarters. Now that answer of 104.88 is in the memory called answer. So when I press equals, the calculator will just add another quarter of 9.65%. That's how much I've got after 3 quarters. Now, for the last time at the end of the year, I end up with 110 Rand. It's exactly the same to get 9.65% per annum compounded quarterly as 10% compounded once. Okay, does it make sense? It always makes sense. All right. Okay, number 3. I want you guys to try and do this question. I'm going to give you the formula. Here's our compound interest formula. How long will it take for an item to double in price? Okay, so inflation is 6%. How long will it take for an item to double in price? If it starts off at P, what's double? 2P. Did anyone use a number here rather than P and 2P? What if it was 4 Rand? What would it have to become? 8 Rand. If it was 40 Rand, 80 Rand. But what you'll see is every time when you divide, what do you get on the left-hand side? You're just going to get 2. Yeah. We're going to need to use what to find N? Logs. Okay. So N will be log base 1,06 of 2. What do we get? 11,9. So it actually says to the nearest year. All right, 12 years. 12 years. After 12 years, the thing will have doubled in value. All right. So maybe if a loaf of bread costs 24 Rand now, in 12 years' time, it's going to cost 48 Rand. It's scary. Okay, inflation is scary. Right. The biggest piece of the matric syllabus is the annuity stuff. All right. So I want us to look now at question number 5. Dali. Dali is a boy that I teach. His name's actually Dalitso, but we call him Dali. Dali invests, he deposits 300 Rand each month. Okay. He does this for 60 months. Then it says, how much money does he have in the account 4 months after making the last payment? This is an annuity, okay? It's an annuity because we're paying every month. It's not just the compound interest formula. It's not just this formula here. This is for a single amount. We're using an annuity. Is this a future value annuity or present value annuity? Future, well done. Okay. Remember, what our future value annuity does. This is payment number 60. This is payment number 59. All right. What the future value formula tells us is the value right here as we make the last payment. What's X? X is 300. X is the amount that Dolly's saving each month. What is I? It's 0.1 over 12. Now, the reason it's over 12 is he's not getting 10% per month. He's getting 10% per year. What is N? N is 60. All right, if we put all of this into our calculator, guys, we get 23,231 and 12 cents. Is that the final answer? No. That's how much money he has in the account as he makes the last payment. When do we want the value? 4 months later. What do you think happens in the next 4 months? We get interest. Cordua, this is not an annuity anymore. This is just this formula here. We're just going to take this amount and we're going to add on 4 months worth of interest. We get 24,000 Rand and 15 cents. Sorry, not 15 cents. 24,015 Rand and 23 cents. And we only round off, guys, at the end here. Are we okay with that one? All right, let's look at number 6. We'll look at number 6 as our last one, and then we'll take a tea break. Okay. Jason borrows 200,000 Rand. He repays it over 4 years, and that's the interest rate. What is his monthly repayment? Now, present value or future value? Well done. For loans, we use present value. Here's the formula. 1 minus 1 plus I to the minus N over I. Right. So all the value, the present value of all his payments is going to be 200,000 Rand. Which variable am I looking for here in this question? I'm looking for X. Guys, what's N? Well done. N is 48. N is not the number of years. N is the number of payments. Okay, so it's monthly over 4 years. So it's 4 times 12, it's 48. How many variables in this equation? Elilodwa, yeah, just one. All right. And so we can work out what this is, and then we can divide both sides by that to get our answer for X. All right, 5,266 Rand and 77 cents. Okay, I think I'm trying to decide whether we do this last question. Let's do this last question. Okay, because we started a few minutes late. So let's do one more question and then we'll stop for tea. I know I promised we'd stop for tea, but this is our last finance question. Okay. Jordan borrows R1 million to buy a house. Those are his repayments. That's the interest rate. How long will it take him to repay the loan? Present value or future value? Present value. Which variable am I looking for? I'm looking for N. There's the house. You can see the house. It's a nice house. Thanks, 15,000, yeah. But this looks, hey, this looks scary. I mean, it's big, it's ugly, it looks scary. But it's just an equation. Where's the variable? It's in the exponent. What am I going to use to find that variable? Logs again, yeah. What can I do first, though? Let's just think, let's divide both sides by 15,000. Now, guys, just to save a little bit of time, when you divide by 15,000, you actually get 1,000 over 15. All right, because the thousands here divide. Do you agree? There were 3 extra zeros here and 3 extra zeros here. And they will cancel each other out. They will divide. All right. Now, this is 1 minus 1 plus 0,1 over 12 to the minus n. This is over 0,1 over 12. I've got a fraction here. What can I multiply both sides by to get rid of the fraction? 0,1 over 12. Okay, so I'm going to get 1,000 over 15 times by 0,1 over 12 equals 1 minus 1 plus 0,1 over 12 to the minus n. Now, I'm going to do two things at once here. I'm going to add this to both sides, and I'm going to subtract this from both sides. Okay, so if we have a look what I'm going to get to, I'm going to get to 1 plus 0,1 over 12 to the minus n is going to be the same as 1 minus 1,000 over 15 times 0,1 over 12. And now I've got something to the power equals some other number. These are just numbers. This here is just a number. Something to the minus n equals all of this. Who can tell me what will it look like if I put it into log form? Minus n equals log. The base is going to be this green stuff. 1 plus 0,1 over 12. And I'm going to find the log of all of this stuff. Right, so it will take 98 months to pay off the loan. Okay, and the last one that we're going to do, That's an important idea as well. All of this stuff's important, which is why we're doing it. But how do we work out the outstanding balance after 30 payments? Who can tell me? What do we do? What we do is we work out the loan interest minus the future value of the payments that have been made. Okay, so if we think about the loan was R1 million. We're going to put interest on it for 30 months. And then we're going to subtract the future value of these payments. And remember, the payments were 15,000 Rand. I'm sorry, I'm getting all squashed up here. Rubber is not working anymore. Yeah, just understand what we've got here. This is the loan with interest. These are the 30 payments that have been made with interest. And the difference is how much he still owes. And it comes to 773,843 and 23 cents. Okay, guys, we're going to stop. Good night, guys. We're going to carry on. We're going to do some calculus. I want to start off just by showing you a sketch. We do have a couple of visitors, but I'm waiting for them to come inside as well. I want to introduce them to you. Okay, so they are coming now. Let's get back to our seats as quickly as we can. So calculus is all about gradients. Okay, it's about finding gradients of things. Now you guys know, I hope you know, that the gradient of this blue line, we can just use our gradient formula. Okay, 4 minus 1 over 2 minus 1. The gradient of the blue line is actually 3. In calculus, we are concerning ourselves with finding the gradients of curves. All right. Now, what you'll see, if I move this point B, okay, a little bit closer, what happens to this average gradient? It's actually decreasing, okay? It's getting smaller. It's getting more and more like it's getting more and more like the gradient of the red lines. Okay, guys, I want to introduce you to, we've got two visitors here. We've got Mr. Mnumzan Malinga, Mnumzan Zulu, okay, and they are subject advisors for mathematics. Okay, now one of the things they've asked me to ask, even to ask the teachers, is when you guys are learning, when you're working now, that the teachers walk around and help you with the examples as well. Okay, so that's that would be wonderful. Okay, but it's very nice to have them with us, and I want to thank them for all the support they give in terms of helping arrange everything with the schools. Okay, guys, do you see that as point B is getting closer, the blue line is getting closer and closer in its gradient to the red line. The red line is the instantaneous gradient at x equals 1. This graph is y equals x squared. What's the derivative of x squared? 2x. So at 1, the gradient is 2. If I move this point A round here to -1, what will the gradient be at -1? Guys, so the gradient is 2 times x, eh? So what will the gradient be if I go around to -1? What's 2 times -1? -2. And do you see at -1, the gradient is -2. If I go to -1.5, what's 2 times -1.5? -3. And you'll see, maybe my hand's not quite, there we go. At -1.5, the gradient is -3. Okay, what I want you to get from here is that the closer these 2 points get together, the more accurately the blue line measures the gradient of the red line. Okay, the blue line is what we call an average gradient. The red line is what we call an instantaneous gradient. Calculus is all about finding instantaneous gradients. I'm going to show you another picture, and it's our picture of first principles. All right. So I've got this point. I want you to find the gradient of this red line. Okay. I've got 2 points. I've got x, f of x, and I've got another point a little bit further away, x plus h, f of x plus h. Do you see your gradient formula here, guys? Y value minus y value over x value minus x value. Do you see the gradient formula there? Now watch what happens. As I move closer, is the blue line getting better or better as an approximation of the red line and for its gradient? Better, much better. So I want h to be, do I want h to be big or small if I'm trying to find the gradient of the red line? Small. How small? As small as I can possibly make it. Kodwa, it cannot be 0. Okay. One of the things that I can almost promise you is going to come up in your trial exam. I can't promise you, but I can almost promise you, because I haven't seen the trial exam, is first principles, to differentiate by first principles. This is an easy thing to do because we know the answer. What answer do we get when we differentiate minus x squared plus 3x? What will we get? Negative 2x plus 3. Now, I'm going to ask the teachers to walk around. I want all of you to try using this formula that you get given. I want you to try and get this answer. Pay careful attention to the notation. Here's the formula. It's on the formula sheet. F of x plus h minus f of x over h. Okay, see if you can get this answer. I'm sorry, I didn't leave you too much space here. Okay, and some of the teachers are going to walk around and check how you are doing. I have put on the WhatsApp group for the teachers who are remotely, I have put the solutions as well. So you should have them. And Mr. Zulu will put on any other groups that he's on, he'll copy those across as well. What does f of x plus h mean? It means put x plus h where all the x's are. algebra here. We've got to multiply this stuff out. Most important thing here, where learners make a mistake, is that forget these brackets. Do you remember the fish in the house, guys? The fish and the house. When we square the first term, notice all of them are going to become negative. So it's going to be negative x squared. 2xh, negative 2xh. Minus h squared. Plus 3x. Plus 3h. Minus x squared. Minus 3x. Now, we have got h on the bottom. We need to be able to factor out an h on the top. That means that all the terms that don't have h's in on the top must disappear. Look at this. Okay. Look at this. I've made a mistake. Where have I made a mistake? Who can tell me? Yeah, this x squared is not x squared. It's actually negative x squared, which means that this is actually a positive x squared. Okay, this and this are going to cancel each other out. This here is also going to disappear. Now, everything on the top has got an h in it. What I'm going to do now is I'm going to factor out an h. So I've left so little space here. That was silly of me. And I'm going to get negative 2x minus h plus 3 over h. Now, guys, h is not 0. H is tiny, but it's not 0. Because it's not 0, I can divide by h on the top and the bottom. I'm going to write one more line here, which I don't actually need, but I just want to show you something. If I write this line, like this, I'm going to lose a mark. Can anyone tell me why I'm going to lose a mark here? Guys, what's wrong with this here? What do I need? Not this. Are these two things the same? No. What's happening on the left-hand side here? I'm finding the sine of 60, and then I'm adding 2. Here I'm finding the sine of 62. If I want to find the sine of 62, I need to use brackets. I must have brackets here. The reason being is that I'm finding the limit of all of this stuff. You can go from this line straight to the answer. Guys, the notation is very important. Don't forget these brackets. Never put the equal signs here. The equal signs don't go here. They go on the left-hand side. Every line you must write limit. Kodwa, once the h is gone, you must not write limit. Okay, so you're going to write limit on all the lines apart from the last line. And there's our answer. And before we started, we knew what the answer was. Here's 5 marks. Guys, 5 marks that all of you must get. Because it's not difficult. It's just algebra. Okay. We're going to look now at questions where we're using the rules of differentiation. Okay. Before we can differentiate something, we want it to be flat. Okay, I like to use the word flat. That's my own word. All right. That means no brackets. No brackets, no fractions, and no third thingies. Okay, let's look at this question because I think it's an important question. We're going to look at B, and I want you all to try it. You cannot differentiate the fraction until you've got rid of the fractions. So in other words, you can't differentiate the top and differentiate the bottom. Ayikho le nto. Akunjalo neze. Okay. Can I cancel this 8 and this 4 or these x's? Ayikho lento, no ways. Okay. What must I do when I've got fractions and I want to simplify? Factorize. The bottom is easy to factorize. What's the bottom? 2 and 2? X minus 2. So let's see if we can take out an x minus 2 on the top. Okay, let's just let people have a chance to look. See if you can work out what must go inside here. X squared. Okay, x squared, I think most people are happy with the x squared. They are going to get x squared here. All right. Then what must I have here at the back to get the minus 8? Plus 4, minus 4. Plus 4. Because that's going to multiply there. Mind you, if we multiply this out now, we're going to get minus 2x squareds. How many x squareds do I want here? I don't want any x squareds. Okay, I don't want any x squareds. So what I'm going to write now, I'm going to write plus 2x. Because these two x's will multiply with this x to give me plus 2x squared. This is correctly factorized now. Now, can I divide the top by x minus 2 and the bottom by x minus 2? I can. Okay. I'm going to write this now. I'm going to divide each of these terms by 2. Watch how I'm going to write it. Half x squared plus, what's 2x divided by 2? X. And 4 divided by 2? 2. Have I differentiated it? Not yet. Okay. What's the final answer? X plus 1. Hala. Kodwa, I've lost some marks. Why have I lost marks? Watch what I've said. I've said f of x equals. This is not f of x. I equal. This is f dashed of x. Don't call this f dashed of x. This is not f dashed of x. This is still f of x. This is still f of x. This is not f of x. This is f dashed of x. Okay, there are different notations that we've got to be able to deal with. This one says, find the derivative of this stuff. Okay, now, are there brackets? Yes. Are there fractions? Yes. Are there square root signs? Yes. It's not ready to differentiate. I'm going to write this. Someone to tell me, what must I put inside here to get rid of these fractions and brackets? And remember, I've told you, well done. 5x to the negative 2. That's an exponent idea, huh? What about this? Another sort of exponent and third idea. Well done. Remember, this one goes on the numerator, this one on the denominator. Now, don't think I must change this to 5 to the half. Root 5 is just a constant. It's just a number. It's just like 7. When we differentiate it, what's the derivative of 5? 0. What's the derivative of root 5? 0. Now, guys, I want you to pay careful attention. Look here. This is still here. Have I differentiated it yet? No, I haven't differentiated it. Now I'm going to differentiate it. What will the answer be for 5x to the minus 2? Negative 10x to the minus 3. 4/3 x to the 1/3. 4/3 minus 1, 1/3. Okay, that's the answer. Sometimes the question will say with a positive exponent. Well done, negative 10 over x cubed plus 4/3 x to the 3rd. Okay, this, I'm not going to do this question, but this works exactly like the other one. Don't leave this out until you've differentiated it. You see here, the d by dx is still here because I haven't differentiated it. From this line to this line, I'm getting ready to differentiate it. I'm getting it flat. Okay, right. Pendulika, so we're going to go to number 4b. All right. Before we do that, I'm going to show you a sketch. All right. Here is a cubic graph. Okay. And I'm just going to show you that's the value of the function there. All right. There it is over there. Okay. Now, I'm going to now show you the first derivative. There's the first derivative. The first derivative at -5 is 2.2. What does it mean if the first derivative is positive? What does it tell us about the function? It's increasing. Look at this. At all of these points, the first derivative, I'm asking you to watch this blue number over here. The blue number is positive. Okay, what will the first derivative be at this turning point? It will be 0. Allah, Allah. What will the first derivative be when the graph starts going downhill? Negative. Good. Now, I want you to, okay, what will the first derivative be at the other turning point? 0 again. And then it goes positive again. Okay, now, I'm going to show you the second derivative. Okay. In fact, I'm not going to show you the second derivative yet. I'm going to show you the first derivative. I'm going to ask you to watch the first derivative again. Is the first derivative increasing or decreasing? It's decreasing. All the time here, it's decreasing. It's still decreasing. Somewhere over here, it starts to increase. It's getting bigger again. All right. The second derivative tells us about the behavior of the first derivative. Because the first derivative is decreasing, the second derivative is negative. Do you see the second derivative is negative? When the first derivative starts to increase, the second derivative goes positive. All right. We've got a point where that changes over. That's called the point of inflection. That's there at B. All right. I'm sorry, I'm going to make this quite a lot bigger, and I should have done that already. Let's just go to there, right? Then we'll actually be able to see. All right. But you can see the first derivative, the second derivative, and the function value. Notice, as I go past the point of inflection, the second derivative becomes positive. This piece of graph here is concave up like a cup. Okay. This piece here is concave down like a frown, like a sad face. Concave down. Okay. Concave down like a frown. The second derivative is negative. Concave up, oopsie. Concave up like a cup. The second derivative is positive. At the point of inflection, the second derivative is 0. Okay, let's look at this question now. All right, we're looking at question 4b. And it says, when is this graph concave down? Now, if it's concave down, what do we know about the second derivative? Negative. Allah, Allah. Okay. Concave down, negative. What's the first derivative? 9x squared. 32x plus 23. What's the second derivative? 18x plus 32. Good. And we want the second derivative to be negative. All right. What must I do to both sides? Minus 32 from both sides. Lastly, I must divide both sides. Okay, this fraction can actually simplify. Okay, there it is. This graph, this cubic graph looks something like this. Does the red piece, is the red piece concave down or concave up? Concave down. The green piece is concave up. At -16/9, it changes. Less than -16/9, it's concave down like a frown. Bigger than -16/9, it's concave up like a cup. Okay, I'm going to ask teachers just to also just check here. I want you to find for me the equation of the tangent, all right, on this graph at the point where x equals 2. All right. So what I'm asking for the equation of this red dashed line at that point. And I'm going to ask for a volunteer to tell me how to do this question. All right, Mr. Mabalek is coming with a microphone. Tell us, guys, sometimes you don't know how to do the whole question. You just know how to start. Tell us how to start. Can someone tell us how are we going to start this question? Sorry? Find the derivative, okay? Let's find the derivative. What is it? 2x plus 5. Okay, I want someone with the microphone now. I want someone to tell me what am I going to do next? That's a good thing to do. Even if you knew nothing else, you've got a mark already. Okay, but what next?
We must substitute 2.
Okay, so we're going to substitute 2. And what do you get when you substitute 2? 2 times 2 is 4 plus 5? 9. 9, what is 9? Hinile. Well done. It's the gradient of that line. I'm going to say m equals 9. All right. I want someone else to tell me now what next. I know the gradient is 9. Have I got a point? No, I've got half a point. Who can tell me what am I going to do next? Let someone put your hand up. Come. Let's get a volunteer. Don't be shy, guys. Remember, I've told you this story before. You go and interview for a job and they say, what's your name? And you say, they say, sorry, I can't hear you. Don't do that. I'm Paul. No, I mean, you're Paul. Okay. Okay. Tell us what to do. Well done. How? On which formula? This one or this one? That? Hala. Well done. Okay. So we're going to put 2 into here, guys. Can you tell me what you get? Have you worked it out or not? 4 plus 10, 14 minus 3 is 11. Well done. Okay. I think this man deserves a round of applause. Okay, now we have a gradient and we've got a point. Who can tell me what's next? Okay, I'm getting a volunteer with a microphone. You've had some help. I heard someone say y equals mx plus c. Tell me what I'm going to do with this mx plus c. Someone, put your hand up. Say, I want to talk. I want to talk into the microphone. Maybe my name is going to be Beyonce one day or something. Okay, you can even sing. If you want to sing into the microphone, you can sing. There we go. We've got a hand up there at the back there. We got a hand somewhere closer. You can pass the microphone over. Okay, now we go on here, yeah. Okay, so what am I? Just tell me what to write. Yes. Yeah. Yeah. plus C. Okay, well done. All we don't know now is what C is. Huh? So 11 is 18 plus C. What should I do to both sides to get C? Minus 18 from both sides, and I get C is minus 7. Final answer, y equals 9x minus 7. All right. Okay, really, really important skill and important idea. Okay, Penduli Kasi, we're going to look for question. In fact, I'm going to do one more before I hand over I'm going to ask you to do question 7 on page 19. This question, find the point of inflection of this graph. And guys, they want the point. Remember, point's got 2 pieces to it. Let's get a volunteer to tell me something that I can do first. Anything. What should I do just to get started? Get the first derivative. Someone take that microphone and tell us what is the first derivative. I'm wanting someone with a microphone. Here we go. You're getting the microphone, whether you wanted it or not. Yeah. Three x squared plus 12x minus 8. Well done. Just keep the microphone because I want to keep talking to you. All right. What should I call it? Because if you just write this down, guys, the examiner, the person marking your book now, your work, they don't know what you're trying to do here. What is this? Yenile. What should I call it? With the microphone. What should I write here? Yeah. So I can write y dashed or y prime like that. Okay. All right. While you've got the microphone, just keep talking to me. Okay. I'm enjoying our conversation. Tell me what I should do next. Okay, and what should I call it? Okay, so I'm going to go y dash dash. Guys, you can also call this dy dx. This one's a bit funny. It's d squared y over dx squared. I think the y dash dash is a bit easier. Okay, tell me what is the second derivative? 12. Okay, now what am I going to do next? Equate to 0 because at a point of inflection, the second derivative is 0. Okay, carry on. Solve this little equation for us. You want some brackets? I don't. Okay, good. I'll get 6x equals minus 12. Yeah. Yeah. -2. Good. Okay. Am I finished? No. Okay. I'm not finished because that's not the whole point. That's half the point. Where must I put this? Must I put it in the second derivative, the first derivative, or the function? Well done. I must put it in the function. All right. Guys, to save time, I'm going to copy my answer down here. I can tell you that the answer is 45. Okay. I'm going to hand over to Mr. Mabalega now. When we did equations, if you guys were paying attention, you might have said, hey, Paul, we didn't do simultaneous equations. And the reason we didn't do them is we're going to do one now. Okay. And I'm going to. Yeah. Just sit down and have a look at it. Good idea.
Yeah.
Okay, let's try this question. I think. Cool. I'll just put a plaster on Mr. Mabalega. Now it's going to be fine.
Okay, anyone an idea of how we're gonna approach this question?
So we've got to do something. If we do nothing, zero. We've got to try something.
So what information are we given? So the function y is equals to ax squared plus bx minus 2 has a gradient of 9 at this point. And we're required to find a and b. Okay, so what do we know about this point? This point lies on this function, right? Okay, so we can sub it in. Okay, let's quickly do that. Yeah, so if you sub it in, so I have 7 is equals to a 3 plus b times 3 minus 2. Okay, can you see that I'm going to get an equation in terms of what? In terms of a and b. Okay, so 7 is equals to 9a plus, okay, minus 2. Okay, and then can I call this equation 1? Okay, because I have 2 unknown variables, right? So it's quite clear that I'm going to have to use simultaneous equations to solve this problem.
She's got one problem.
Mm.
Anybody want to tell me how to find another equation? Put your hand up if you want to tell me. Where? Yeah. Every time. Yeah. So, it's all one word. As the
Yeah, so we're going to find the derivative of this again. Yeah, so y prime is equal. So what's the derivative of this? 2a x plus b. Okay, so how do I move? Okay, so at this point, right? Hold on. Okay. So I'm gonna say, so what do you say? It's equals to 9. Okay. So 2ax plus b is equal to 9. Okay. What like there's something missing here. So we're told that this gradient, so the gradient of this function is equal to 9 at what point? At what point? At that point. And x is 3, right? So if I do this, if I say 2a is equals to 9. Okay. And so this gives me what? 6a plus b is equals to 9. Okay, do I have my second equation? Okay, so I'm going to call this equation 2. Okay, now how do I solve? Okay, for a and b simultaneously. Okay, I have a number of options. Either eliminate, substitute, or equate. Okay, so what am I going to do? Any ideas? You want to continue with your? Yes.
Okay, now, how come these three pieces? No. These three pieces. And then multiply three. What now? Three. 37. And then multiply three by three. Now, what is the big now to eliminate the fees? So the answer is right? So what we get, I'm not going to put it like this, but if we put it like this, it's not minus 36. Negative now a minus 18. Negative 9. Why did I still have one? You got one variable. Okay. Now what should I do the first side? Negative 9, the negativity is related to the negative, the number of the negative. Negative 9 is going to be.
Okay, play my done. Now I still need to find the value of b. Okay, so how am I going to do that? Substitute. So substitute a in either equation 1 or 2. Okay, and just to save time, should I? Yeah, b. B is equals to minus 3. Okay. Cool. Yeah, let's move on to question 9. Yeah, so we give it.
Yeah. That's.
So, any volunteers for the first question? What does the question mean? What does the question mean? Okay, let's start there. What does the question mean? F of x is less than 0. What are they trying to find out? Where what? So where the graph is below what? The x-axis. Yeah.
Folks is one, and folks is four.
Okay, which, in between,
Please.
So it's this.
Between 1 and 4.
Yeah.
One. And four.
Okay. It's the fun.
Okay. Four.
We can. X, X element of 1 to 4, long bracket to 3 bracket. Long. X is the element of 1 to 4 with long bracket. Is it even? Or yeah. So negative report negative concentration less than negative. That's also the rock that we it's about x to the element of minus infinity up to with minus 7. First with the ground bracket. Right. Then look at the next one. F dash of x. Now f dash this. What tell me what f dash mean? What is it? And what does it mean if it's bigger than 0? I'm looking for volunteers. Just tell me what the plot will look like if f dash of x is bigger than 0. Why do you do the concavity? Concavity because it is different relative. Or, oh, I'm sorry. Are the two guys to go up?
Oh, there's one.
Look up. The next day, we take a look.
Hmm?
I think that if we reach out in the negative zero,
You will look at it. At the point of click,
I think it's like to be less than negative.
Less than negative 0.66.
what is it? It's the gradient. Okay. What is the gradient that is positive or not? It's got a positive value. I'm gonna ask Mr. Adelaide, just to cover the pin somewhere on the graph. Anyway, you can put somewhere.
Oh, yeah. Okay.
Now, the gradient positive or negative there. Positive there, okay? So, and when you positive, when you go on a positive, negative 4. X negative 4 equal to negative 4. And we can to negative 4 equal to equal and negative 4 to be 0. And we say this. Now, somewhere else, we look for the uphill where yeah. So how are we gonna start? Start right. Thank you, sir. You got this. Okay, right, now it gets slightly more complicated because in C, guys, in C, we've got a product
Actually, it's
of two things.
it's a mistake on the.
The
Yeah, it should be F1. So the second derivative is less than 0. So the question is where the second derivative is less than 0.
what, right?
Yeah, the question, yeah. C. Yeah. Yes. Oh yeah, yeah. It's fine, it's fine.
Yeah.
Yeah.
Guys, how do we get two things multiplying together and giving up the puzzle? They both negative, normal, they both positive. Yeah. What if we get talking about the y value of the graph? What if demonstrate x talking about the gradient? Okay. What does a positive gradient look like? We're just talking about the graph is increasing. So if I want both of these things to be positive, I want the y value to be positive, I want it to be above the axis and increasing. Maybe you can just write down this number like that, above and increasing. If it's above and it's increasing, both of things will be positive. You can tell me where is that graph above the axis and at the same time it is increasing? Where does it go above the axis for the first time? Negative 6, okay? And then is it increasing? So okay, so from negative 7 to negative 4, maybe you didn't do my time, it's element of. That's right, it's element of negative 7, negative 4. Okay. Yeah, we can have square brackets, thank you. Now, guys, where is the graph increasing and above the axis? Good. Or x is element of 4. So I put a square bracket or a round bracket on that 4. Icon. Square. Okay. I want a square bracket because I want to go from 4. Become that a little bit. Yeah. X is element of 4 to positive infinity. Guys, we never put a square bracket on an infinity sign. Okay. So infinity and then a round bracket. Okay. Now we're not going to do the last one. All right, I'm not going to do this one, it's going to be short time. But I'm just going to ask you to number to get to right here.
It's
How do we get a negative product? We want 1 plus 1 minus or minus x plus. What? And I want you to study in way. What? The first derivative positive and the second derivative negative look like. The graph must be going uphill but it must be the second derivative negative means the graph must be concave down. So I want to write down increasing and concave down. What other thing it could have? This could be negative. What is the negative derivative become? Decreasing. And this concave up. So it could be decreasing concave. Going to yeah, so we've got this equation. Is that right? Now look, example. Okay. Page 16. Okay, now this is an optimization problem. Okay, we want to work out. So the first part of the question is going to make a square, and he's going to make a circle. What will the area of the square be, guys? He's going to each of the sides of the square are going to be x. What will the square look like? Because a nice neat square should make a nice square for you. I think it's the square. So try and angle it. That's fine. Yeah. So guys, that's x and x. And what else? Also x and x. Okay, what's the area of what will be the area of the square? X squared. Easy. Okay. Now this he now makes the circle with the rest of the. How much room has he got left for the circle? So he has 100 centimeters of rubber. Now he used some to make a square. How much did he use to make a square? X plus X plus X plus X. 4x. So well done. The remaining rod would be 100 minus 4x. Now, when you make that circle, what circle first? Yeah, when you make that circle, what is the 100 minus 4x represent? Does it represent the length, the diameter, or the circumference? Well done. It represents the circumference. So we know that the circumference is 100 minus 4x. Now, you can remember, what's the formula for circumference? If we're going to have the formula, circumference is pi times diameter. Pi times diameter. So can I get diameter now? What does that do to get the diameter? Divide both sides by pi. Does anyone know how I'm going to work out the area of the circle? What's the formula for the area of the circle? I R squared. Guys, you don't just give me formula, it's going to know these two formulas, it's just the numbers as the data. If I know the diameter, so this is not really the radius. Divide by 2, then divide by 2 is 500. So it's really,
Yeah.
yeah, it's not something that is what it's going to be 100 minus 3. Or now, yeah, you can be 50 minus 2. Right? If we divide by 2, it will be 50 minus 2. So we halving, we divide the top by 3. Okay. Yeah, just click like the 6 value of it. Yeah. 50 minus 2x over 5. And what will the area be? And the area is pi squared. It's going to be all of that stuff. Squared. Okay, that's what that's going to be the area of the function. Then it's what value of x will make that area as small as possible. Okay, so let's write down any area and add them both together. So it's squared plus I'm gonna discuss what we have. I'm gonna split it up. 50 squared is 2,500. 25. Remember the half million account. 50 times 2 is 100, so minus 200 x plus 4x squared. Okay, over 5. Okay, now, guys, let's go. But when it is at a minimum, you can what is P at the minimum? The gradient. Okay, so we will make up the derivative now. That I'm worried that we are that's not yeah.
So right.
Yep. That's it. What's the derivative? Yeah, now, I'm following the system that we can now. On the wall, we can find the okay. Now, the derivative of the what's the derivative of 2,500? Yeah. The derivative of negative 200, negative 200, and the derivative of 4x squared, 8x. Okay, and we want the gradient to be 0. Now, guys, this is not an easy question. I know that. How many variables are we get? Remember, pi is not a variable. There's only one variable there. We should be able to solve for it. If we multiply both sides by pi, we're going to get 2 pi x, okay? 2 pi x minus 200 plus 8x equals to 0. All right. Now we can add 200 by 5. And we get we just beginning to that because we did one where we had 7 8, sorry, 7 8. But 2 markets. And then the mark was bar. Okay, and we get to It works out to 14. Okay. An interesting question. Question. Thanks, Mr. Mamaleka. We're going to move on to some function stuff. Remember that the thing with optimization is we want one variable in our equation, and then we find our derivative and make the derivative equal to 0. Okay, all right, I know it's a long morning, and I know it's quite hectic doing all this math. So we've got 2 more topics to go. There are functions and inverses, and then some probability. Functions and inverses, very, very big topic, very important topic. So we're going to spend a little bit of time on it. Okay, and I want us to try question 2. Domain and range. Now, if I say to you, fish in Hlanzi, all of you are picturing, I hope, you're picturing the same thing. You know what a fish looks like. What is this? Hinile, what sort of graph? It's a hyperbola. Okay, what will its domain be and what will its range be? X not equal to 4. And the range? Y not equal to 3. I've taught you guys before, and you've heard me talk about vanilla functions. The vanilla function here is like this. Okay? And it never hits the x-axis, and it never hits the y-axis. Those are the asymptotes. Okay, so for the vanilla one, the domain is x is not 0, and the range is y is not 0. This graph has been moved. How has it been moved? What is that? How much does that move it? Which way, and left or right? Right by 4. So this asymptote that used to be x equals 0 is now going to be x equals 4. X is not allowed to be 4. We would be dividing by 0. The range is normally y not equal to 0. What does this do to the graph? Shifts it up by 3. Okay, right, good. Who can tell me, what does a log graph look like? Can you guys draw a log graph in the air? Log base 2. Log base 2 x plus 4. All right. Guys, a log graph and an exponent graph. If the base is bigger than 1, it goes uphill. But the log graph has got a vertical asymptote. All right. What does the plus 4 do? 4 to the left. All right, guys, that's what that graph looks like. This line here is x equals minus 4. So who can tell me what is the domain of this now? Remember, domain is our x values. X bigger than negative 4. Yes. So, yes.
Because we lost That's what I was saying, it's actually essentially. It's literally the data stream, what's in the data. And I'm talking about the diagram sheets. I'm not talking about the measurements. I'm talking about the diagram sheet. So if ever you ask for that, the image forms and yes, answers in the same. Once you look around, we see some diagram sheets, because if they want to, as in paper small, it's shrinking. Okay. Doesn't it make the shapes?
That's great. Thank you. All right, guys. So the domain of this graph bigger than -4, the range y can be anything on a log graph. All right. Let's look at this graph. 0,5 to the x minus 9. It's an exponential graph. Is it going uphill or downhill? I can't. Guys, it's going downhill. It's all about the base. Remember, I played you the song before. It's all about that base, about that base, about the base. Okay? It's going downhill. So if I just drew 0,5 to the x, it looks something like that. What does the -9 do? Shifts it down by 9. Okay. Shifts it down by 9. Now, what that means, if we look now, this line here is y equals -9. Look at the domain of this. X can be anything. But what about the range? What y values can I get? -9, I can get anything bigger than -9. Yes. Yes. Yeah, so it's interesting. We don't require that. So you require that. Okay. So you must actually say x element of the reals, y is an element of the reals. Okay. So in the exams that we write, we don't have to say that. Okay, which is interesting. Okay, and the same here, we should say x element of the reals. So that's just a habit that you need to get into. Okay, this one here. What sort of graph is it? Is it a straight line? Is it a hyperbola? Is it a parabola? Is it an exponential? Is it a log? What is it? It's a parabola. The vanilla one, guys, -x² looks like this. That graph there is y equals -x². Cordwa, what does +4, if we add 4 to the x's, what does it do to the graph? Shifts it which way? 4 to the left. If we add 9 at the back, which way does it shift it? Up 9. So now, guys, if we move this graph, 4 to the left and 9 up, it's going to be somewhere here. What will this point here be? -4, guys, because it was 0, 0. And you told me it's moved 4 to the left and 9 up. So -4, 9. What's its domain? The domain of a parabola, x can be anything. What about the range of this parabola? Y less than or equal to 9, okay? And y is an element of the real numbers. But I'm just going to do, I'm going to do question 3A. You might remember earlier we completed the square. Completing the square is such a useful thing to do. At the moment, I can't tell much about this graph. I know it's a parabola. If I can write it like this, then I'll be able to tell how it has moved. Have a look at this. What must I put here? Remember the house and the fish from earlier? What must I put here to get 6 when I square it? I must put 3. Okay, now if I multiply this out right now, what do I get? I get x squared plus 6x plus 9. Did I have 9 here? No, I need to minus 9. Now you might be saying, Paul, earlier we added 9, but earlier we added 9 to the other side. Now we are subtracting 9 from the same side. Do you agree that if you multiply this out, you get exactly back to here? Because we're going to get the x squared, we're going to get the 6x, we're going to get plus 9, plus 11, and minus 9. So we're just going to get the plus 11. Now, let's just tidy this up a little bit. This is x plus 3 all squared plus 2. Guys, tell me about this parabola. How has it moved? I'm going to draw the vanilla one for you. The vanilla one is here. This is y equals x squared. Okay, and this point here is 0, 0. This graph has shifted which way? 3 left and 2 up. Okay, where will this point go if it shifts 3 left and 2 up? Where will this actual parabola be? Where will it turn? What will that point be? Guys, it was 0, 0. Negative 3, 2. Well done. What's the range now? Do you see how this here is a very useful form compared with this here? When I saw this x squared plus 6x plus 11, I can't tell anything about that other than, oh, it's a parabola. But now I know actually it's a parabola that's shifted 3 to the left and 2 up. All right. What is the range going to be? Y is greater than or equal to 2. And remember, y is an element of the real numbers. Okay. Right. Now, just to tie something in here, how else could I find this point on this graph using other maths? How else could I find the turning point? By making the gradient equal to 0. Okay? Do you agree? Over here, the gradient is 0. So what would y dash be? 2x plus 6. Make that equal to 0. 2x is minus 6. X is minus 3. Now, guys, x is minus 3 is this value over here. How do I get the y value if I've used calculus? Sub it into the derivative or this equation? The original equation. Good. Okay. You see how it's all connected. Everything is connected to everything else. Right. Now we're going to draw 1 or 2 graphs. Okay. The one that I want us to draw first is F. It's this one over here. What sort of graph is it? It's a hyperbola. Okay. All right. Is it in quadrants 2 and 4, Norma 1 and 3? Guys, it's going to be in 2 and 4. I'm going to write down what I would call the vanilla version of this, okay? Before it's moved, it's y equals minus 9 over x. I'm going to multiply this both sides by x, and I get x times y equals minus 9. How do I get, and this we did this already just now with calculus, how do I get a negative product? What do I need? I want one of them to be positive, one of them to be negative. In this quadrant, tell me about x and y. Which is positive, which is negative? Well done. X is negative and y is positive. And in this quadrant, x is positive and y is negative. Okay. In these 2 quadrants, I would get a positive answer here because I would have positive x's and positive y's, or negative x's and negative y's. Okay, so it's in these 2 quadrants. How has it moved? 4 to the left and 2 down. Okay. There are the asymptotes. This asymptote is y equals -2. This asymptote is x equals -4. Right. Now, we know it's in these two quadrants. How do you find, for any graph, how do you find the y-intercept? Let x equal 0, okay? So the y-intercept, we're going to let x be 0. And we're going to get -9/4 minus 2. We're going to get -4 1/4. 4 1/4. So -4 1/4, somewhere over here. So this graph's going to do something like that. And going to do something like that. Goodness. Something like that. Okay. How about the x-intercept? We're going to let y equal 0. Okay. Right, so 0 equals -9 over x plus 4 minus 2. Let's add 2 to both sides. Okay, multiply both sides by x plus 4, 2x plus 8, -9. 2x equals -17. X equals -8.5. Okay, -8.5 is over here somewhere. All right, so it looks something like this. Okay, this thing's okay, right. I'm hoping that will have fixed it. It's just got a little bit kind of confused. Right. So this piece of graph does something like this. Okay. Now, Mr. Zulu asked me just to talk about the axes of symmetry. Right? And there's two ways you can do this. The axes of symmetry are found, right? They on the vanilla, they are just y equals x and y equals minus x. All right, before the graph moves. Okay, those are what we call the axes of symmetry. Now, what will happen is that they will move in the same way that the graph moved. In other words, they will move 4 to the left and 2 down. Okay, so what I'm going to do now, right? What I'm going to do now is I'm going to each of these 4 to the left and 2 down. Sorry guys, my computer is, I don't know, it's its own thing at the moment. It's not kind of cooperating at all. I might have to restart my computer, which is not good because of it. Let's just try. Okay, so I'm going to take this first one and I'm going to move it 2 to the left. Sorry, 4 to the left and 2 down. And what I get is I get y equals x plus 2. And guys, that line there is actually the axis of symmetry of that graph. Okay. I haven't drawn it very well because it should have gone through 2 there, but it will also go through that point. So another way of doing this is to say a gradient of 1 passing through this point of intersection of the asymptotes. Okay. The other one is going to be y equals, have a careful look at this, negative x, but I'm going to move it 4 to the left and 2 down. This one actually simplifies to minus x minus 6. Now guys, minus x minus 6 is actually going to be this line over here. Something like that. All right. But both of them go through that point. So the other way of doing it is actually to just identify this point. This point is -4, -2. Okay, and then you put a line through with a gradient of 1 and a line through with a gradient of -1. Okay. Here we go to question 5, the next page. And you'll notice I've left out lots, guys, but I have given you the solutions. Okay, how do we move a graph 3 to the left? What do we do to each x? We add 3 to every x. And how do we move it 2 up? We add 2 at the back. All right, so just understand, this here is shifting it 2 up. These yellow ones are shifting it 3 left. Okay, it did say, and I'm not going to do it, but it did say in standard form, which means that you would then multiply it out and you just simplify it. How do we reflect a graph in the x-axis? We put a negative in front of everything. Right. On this graph, guys, if x is 1, what will y be? Over here, if x is 1, y would be 3 to the 1, 3 plus 5, 8. But on the red one, if x is 1, what will y be? It'll be -8. And do you see how it's going? The point has gone from above the x-axis to below the x-axis. This computer is just It's just doing its entirely its own thing. All right. It's like, yeah. Okay, so this will be 1, 8. And on the red graph, it would be 1, -8. So it's reflected over the x-axis. How do we reflect a graph over the y-axis? We put a negative in front of every x. Tell me, how do we reflect a graph in the line y equals x? What sort of function, what do we have to do to reflect it in the line y equals x? Well done. We find the inverse. Okay. And the way we find the inverse is we swap x and y around. I'm going to draw this graph for you guys. What sort of graph is it? Is it a parabola, an exponential, a hyperbola? What is it? It's an exponential graph. Is it going uphill or downhill if the base is bigger than 1? It's going uphill. What is the -5 to? Shifts it down 5. I'm going to draw this graph for you. It looks something like this. No. Yeah, guys, I don't know whether to restart my computer. That's going to take some time, and it also means that everyone's going to get disconnected. I'm just hoping and praying it sort of comes right on its own, but it doesn't seem to be. Right, guys, that's roughly what this graph looks like. Okay, 3 to the x minus 5. Now, let's get y on its own here. And I'm hoping you guys are starting to see some sort of pattern. When you've got your variable and the exponent, what are we going to have to use to get it on its own? Log. We're going to have to use logs, all right? X plus 5 is 3 to the y. So what will y be? It will be log base 3 of x plus 5. And guys, that is a log graph that has shifted 3 to the, sorry, not 3, 5 to the left. Okay. And it looks something like this. Okay. And what we've got now, I just want to talk a little bit about this. What we've got is a reflection in this black dashed line that I'm drawing here, in this line y equals x. The purple thing and the orange thing are inverses of one another. Everything has swapped. I want to just explain what I mean by that. What's the domain of the purple graph? Its x can be anything. What's the range of the purple graph? Y bigger than -5. Y bigger than -5. What's the domain of the orange graph? Look here, this is x equals -5. What's the domain of the orange graph? X bigger than -5. And what's the range of the orange graph? Okay, I should say x element of reals here. Yeah, I should say y is an element of reals as well. Okay, the range of the orange graph is y can be anything. Guys, what I want you to observe is that the domain, listen carefully to this, the domain of the function becomes the range of the inverse. And the range of the function, the domain of the inverse, 100%. Okay, so they swap around, and it's not surprising that they swap around because that's what an inverse does. It swaps x's and y's. In other words, it undoes what the original function did. Okay, that's good. Sorry, guys, I don't know whether to restart or what. Yeah. Okay. Oh, and that wasn't a helpful highlight because it's actually just disappeared. Okay. Right. Okay, guys, I want us to look at one last, in fact, two last questions. Question 8. Now, this question, people often get confused by because they think that this question's got to do with the nature of the roots. In other words, I think it's got to do with delta. It has got nothing to do with delta. When we talk about roots, we are talking about x-intercepts. How many x-intercepts does this graph have at the moment? 3. Now, what will adding a number do to the graph? Will it move it left or right or upward, up and down? Up and down. Now, at the moment, it's got 3 x-intercepts. If I pick it up by enough, then it will only have 1 x-intercept. Do you see that? In other words, if this graph, sorry, this thing is almost like this, like someone else in the mouse. I actually don't. Okay. Do you agree that if I pick this graph up enough, it will do that, and it will only have 1 x-intercept? How much would I need to pick it up so that it only has 1 x-intercept? Do you agree I need to pick it up by more than 20,7? So if t is bigger than 20,7, that graph will only have 1 x-intercept. But what if I drop it down? How much would I need to drop it down so that it's down here somewhere and it only has 1 x-intercept? More than 12,6. But now remember, if I want to drop it down, t must be negative. Do you agree if t was, say, minus 13? If t was minus 13, the graph would be dropping down by more than 13. So I actually need t to be less than negative 12,6. Okay, this is quite challenging stuff, but it's important. At the moment, this graph has got 2 negative roots and 1 positive root. Now it says, what should t be now? But look where t is now. Is this, sorry, it's not t anymore, it's k. Is this going to be a vertical or a horizontal shift? Well done. It's going to be a horizontal, a left-right shift. Okay, now what should k be if I want all the roots to be positive? At the moment, I've got 2 negative ones and a positive one. Must I move it right or left? I must move it right by how much? I must move it by more than 4. But remember, if I want to move it right, if I want to move it right by 5, would k be positive 5 or negative 5? Negative 5. So in fact, I need k to be less than negative 4. If k is something like negative 5, which is less than negative 4, this whole graph is going to shift across and I'm going to get 3 positive roots. Okay, it's interesting, but quite challenging. All right, and then the very last question I want us to look at is just finding the equation of a graph. Okay, and there are different graphs here. We won't do them all, but what is this? What's this one's basic equation? It's a straight line. It's y equals mx plus c. What is this? Parabola. It's y equals ax squared, but it's moved. How must we move it? Which one? Where's it moved? To the left and 3 up. Okay, I'm not doing all of them. I'm going to do this next one properly. What sort of graph? Hyperbola. What's the basic vanilla form for a hyperbola? Y equals k over x. But this one has moved. It shifted where? 3 to the left and 6 down. Guys, this equation is going to be this is unbelievably irritating. I can't, like, see, I'm not even, like, I'm not moving it now. It's just, it's like, I must either laugh or I must cry. And I've learned that if you're going to laugh or cry, then laugh rather. Okay. All right. Guys, this is k over x normally, but it's moved 3 to the right. So x plus, it's moved 3 to the left. Yeah, so x plus 3. And it's moved 6 down. Now, what's the last thing I'm going to do to find k? I'm going to substitute in this point. Okay, I'm not going to do it. I'm going to substitute. Remember that this is x and this is y. I'm going to substitute them in, and I actually get k equals -4. Are you surprised that k is negative if it's in these quadrants? No, you shouldn't be. The final answer here is -4 over x plus 3 minus 6. Okay. All right, guys, we're going to move on to our very last topic, and that is probability. Okay, and we're on page 23. You only get 2 formulas for probability. You get this one here. And you get this one that I'm about to write now. All right, guys, these are the only 2 formulas you get. All right, remember that this symbol here means or, and this symbol here means and. Okay. The last, this one here is probability of E is the number of elements in E divided by the number of elements in the sample space. Okay. Now, you don't get given the formula that I'm about to write now, but it's important and you need to know it. The probability of A and B is equal to the probability of A times the probability of B, only if A and B are independent. Now, if we toss a die and we draw a card, do you think those things are independent? Because they're independent because what happens on the die does not influence what happens on the cards. Okay, so this now we're just going to multiply. What's the probability of an even when you throw a die? Guys, this is this formula here. There's a total of 6 things that can happen. How many of them are even? 3, 2, 4, and 6. So this is 3 out of 6. What's the probability that you get a spade? Now, there are 4 suits. Spades is one of the suits. So it's actually 1 out of 4. All right. What's the probability of less than a 3? 2 out of 6. And what's the probability of getting a black card? It will be half the cards. It's 1 out of 2. Okay. What's the probability of getting an even or a red? Now, guys, I'm going to use this formula here. Okay, what's the probability of an even? It's 3 over 6, it's a half. What's the probability of a red? It's also a half. What's the probability of a red and an even? We're going to multiply those two together. Because they are independent, the probability of both of them will equal the product of the probabilities. This actually works out to 3/4. This one here works out to 1/6. And this one here works out to 3/24 or 1/8. But 3/24, 1/8, yeah. Okay, now this is a really, for me, this question here is very, very important. Okay. It says probability of A is that, probability of B is that, and the probability of both, this is and, is that. Now, it asks us, are they independent? Okay, and we've got to now try and answer that question. Are they independent? So the way we're going to check, we don't know what A and B are, so we can't answer any other way other than by doing a calculation. The probability of both of them together is 0.25. What we're going to do now is we're going to work out what's the probability of A times the probability of B. And this comes to 0.4 times 0.5. Now 0.4 times 0.5 is 0.2. Are they independent? No. Guys, they are only independent if those two things are equal to one another. So they are not independent. What does mutually exclusive mean? It means they cannot both happen. Are they mutually exclusive? Guys, mutually exclusive means they cannot both happen. It means it's like saying we've got a learner at Shea O'Connor and the same person's also a learner at Dabula Mans. No, can't happen. Okay. You can, non-mutually exclusive, both things can happen. Being a learner in grade 12, being a learner at Dabula Mans. Yeah, you can be in grade 12 and be at Dabula Mans. Okay. Now, these are not mutually exclusive, right? And the reason they're not mutually exclusive is that the probability of both is not 0. If things are mutually exclusive, then the probability of that they both happen is 0. Okay. Guys, I am just checking the load shedding. I'm pretty sure our load shedding is going to maybe not. Yeah, it's at 1 o'clock. Okay, so we cannot go past 1 o'clock. At 1 o'clock, it's going to get very dark in here. Okay, all right. Now I'm going to draw a Venn diagram, and the Venn diagram is going to help us understand what's happening here. Remember, when we draw a Venn diagram, we start in the middle. Mr. Mabalega here. So, okay, it's now. No, I'm just bizarre. This thing is okay. Now it says it's not responding. Oh my goodness. I tell you. Okay, that's what. Like, all right, guys. It's just such a waste of time to restart the computer, but yeah. See, it's not like it's properly pleasing. All right, guys, I'm gonna just try and reload it one more time. All right. And let's just see if we can draw this Venn diagram. We are Siazam. All right. Okay, guys. Who can remind me when I draw a Venn diagram, where do I start? I start in the middle. Okay. What we know is that the probability of both things is 0.25. Zero comma 0.25. Now we know that the probability of A is actually 0.4. So what must go over here? 0.15. Thank you. And the probability of B is 0.5. So what must go over here? 0.25. Thank you. Now, if we add all these things together, we get 0.4, 0.65. That means that the complement, the balance, must must be 0.35 outside here. 0.35. Okay, now the reason that this diagram is so important is it helps us understand why this rule works. When we say the probability of A or B, I want to show you what the formula says. It says probability of A, this is on your formula sheet, on that yellow sheet, minus the probability of both. Now, watch why the formula works, guys. When I add the probability of A, watch that, to the probability of B, watch that. What mistake am I making? What am I doing? I'm counting this middle piece twice. Do you see what's happening? I'm counting it as probability of A, and I'm counting it as probability of B. And that's why I have to subtract it. Okay, so you can see why the formula works. The formula is actually going to say add 0.4. So we've got 0.4. We've got 0.5. Now that's not the answer, because when we add 0.4 and 0.5, I'm actually counting that middle piece twice. So I now need to subtract 0.25. That's the probability of both. Sorry, guys, this is just so frustrating. It's just like, it's just doing its own thing. All right, and we get our final answer of 0.65. All right. Guys, something here that one of your teachers told me, which I think is also a slight difference, is that what I meant here with this line, I meant the complement. Now, I think on your exams and workbooks and tests, maybe it's like this. Okay, it means the same thing. This means the probability of A and not B. Guys, what's the probability of A and not B? 0.15. This stuff inside here is A, but it's not B. It's A and not B. Right. Okay, pendula ikasi. All right, I'm going to leave that. I'm going to leave that. And I'm going to just end off with some counting techniques. Okay, so we're on page 25. All right, so what this says is we're going to make number plates, and they're going to have 3 letters and then they're going to have 4 numbers. All right. So an example might be GRG 9341. What they tell us is that the numbers may not be repeated, but the letters can be repeated. They also tell us that we will not use any vowels. All right. And sometimes if you have on a number plate, if you have a vowel, then you might have a number plate that, I don't know, that looks like, I don't know, you might have something like that. Okay. All right. And so maybe we don't want that. We could have worse than that. Okay. We could have something like, we could have like F something K or something. Okay. Like, all right. And maybe we don't want that. Okay. All right. So guys, let's just understand, we're trying to build this number plate and we've got 3 letters. And then we've got 4 numbers. Now, how many choices have I got for the first letter? We're not allowed to use the 5 vowels. 21, well done. And then I must multiply. How many choices for the next letter? 21. No, guys, it's 21 again, because letters may be repeated. And another 21. Then, now for the digits, there are 10 digits from 0, 1, right through to 9. Now, there's a choice of 10. Chord 1. Now, there's only a choice of 9 because I cannot repeat 8 and then 7. I'm not going to work it out. That's the answer. Okay, you would type it into your calculator. Right, now look at this question because it's a slightly more interesting question. Okay, we are using these digits. Okay, all right. Guys, how many 3-digit numbers? We're not allowed to repeat digits. So if I'm making 3-digit numbers, how many choices have I got for the first digit? 5, and then 4, and then 3. I can make 60 3-digit numbers. Then it says, how many numbers are possible altogether? This is an interesting question because if they are 1-digit numbers, I just want 1 digit, I could make 5 different 1-digit numbers. Okay, if they are 2-digit numbers, then I could make 5 times 4. I could make 20. If they are 3-digit numbers, all right, we've already worked out that there's 60. If they are 4-digit numbers, then we have worked out, we haven't worked that out yet. It's going to be 5 times 4 times 3 times 2. It's only a 4-digit number, so 5 times 4 times 3 times 2. That's 120. And then lastly, guys, if they're 5-digit numbers, there would also, then it would be 5 times 4 times 3 times 2 times 1. It would be 5 factorial. It's also 120. So actually, there's 240, 325 numbers. Okay, then the question says, what's the probability that a randomly selected one is bigger than 4,000? And guys, I'm going to stop there. I'm not going to answer that question. All right. It can't, do you agree? It can't be a 1-digit number. If it's going to be bigger than 4,000, which ones do I need to count? All of the 5-digit numbers, but also I need to count, and you need to just think about this. I need to count some of the 4-digit numbers. Because do you agree, if it starts with 4, it will be bigger than 4,000. Or if it starts, sorry, not with 4. If it starts with 5 or 6 or 7. Okay. So we're not gonna have time to finish that before we go now, guys. So can I just thank you all very much. I'm sorry the technology is a bit frustrating. I know we haven't finished all the examples. We wouldn't, okay? Your teachers have got the model answers. And so I really encourage you to try before next Friday to try and do the rest of the examples.